Today we will go to the next tab, that is component tab. In component tab, we have these different definition properties of superstructure and substructure. Super and substructure are the content of another lecture. Today we will be discussing the content of this tab, that is materials. So, okay. Are you guys hearing me clearly? My screen is visible to you? Yes. So we use different type of material in bridges. Mostly that is concrete, reinforcing steel, tendons. These are the three main types of material that we use in bridge construction. Steel bridges are all steel is also used for bridges, but we will not cover that in this course because it is uh, another another type of material that is a bit advanced. So typically in RC bridges, reinforced concrete bridges, we we used concrete ranging in strength from 4,000 and above. 4,000 is used for reinforced concrete and precast concrete as well, but mostly for reinforced concrete we use this one. So this is the an S2 class 5.4.2. This I have taken from the S2 2006, which I had previously shared with you. So the specified compressive strength for precast concrete and deck shall not be less than 28 MPa, that is 4 KSI. So the minimum strength that is specified by this ASHTO is 4 KSI. You cannot use strength below this one for pre-stressed concrete, but we also do not use uh, below 4 KSI for RC T-beam as well. 3 KSI strength we have never used in bridge construction. In buildings we use it 3 KSI, but in bridges we don't use any strength below 4 KSI. Uh, you see that this is a statement given by Ashton, so that concrete with strength below 16 MPa or 2.4 KSI should not be used in any in structure applications. So for example, structure applications mean for beams, for girders, for piers, for transoms. Other structure for sidewalks and pedestrian walks, you can use this strength, but for structure application, for use in beams and foundation, you cannot use strength below 2.4 KSI. These are the different properties, and these are the equation that we use that are given in the ASTO. I will share the lecture with you. You can check these equations. These are in Newton per millimeter and MPa. So you have to take care when you use these equation for calculation of modulus of elasticity and other properties, that these are in Newton millimeter. So the other material that we use is reinforcing steel. So reinforcing steel typically has a modulus of elasticity of this and specified strength up to 100 KSI. The other material that is very common in bridges is precessing steel. So these are the different type of precessing steel. So in the previous version, there were two grades specified in the code, 270 and 250. So in the latest version, they have removed the 250. 250 is no longer used in bridge construction. So that's for strand type of material, we typically use this 270 KSI low relaxation strands. These are the tensile strength. This is the tensile strength, and this is the yield strength of this 270 KSI strength. We also use bars, pre-stressing bars. So pre-stressing bars are typical bars, high strength bars, which has a strength of 150 KSI, and they are also used in some construction. So how we define these different type of material in CSi Bridge? So let me show you. So under this tab, we have these five definition. One is the material properties, the other is frame section, cable properties, tendon properties, link properties, and rebar properties. So link properties, I told you previously that it is not and comes under the scope of this course. It is a bit advanced topic. So I will open these tab one by one and show you how can we define these different materials in the CSI. So the first thing is material properties. So when you select material properties, same like the previous steps, it has the same features. The first one stands for new, the second one for the copy, the third one is for if you have previously defined a material, and the fourth one is to delete a previously defined material. So if you click this arrow, this will open. Okay, someone mic is open, so let me check. Okay, so I will open the drawing, the case study that we are using for this course. So this is the typical bridge that we are using. So this is a typical RC bridge. So all the material used in this bridge is all concrete used in this bridge construction is 4000 psi or 4 ksi. So the concrete in the beams, the transoms, the piers, and the footing and the piles all are 4000 psi strength concrete. So if these are already defined, but you how can you define? So you click here, it will open this window, and it has these four sub tabs. So the first tab is for the region. For example, if you are working in another region, so you can select that. So it will change the standards to that automatically. JTG for Europe, it will change European standards, and for New Zealand, it will change to AS. So we are in Pakistan mostly use US standards. So I will select US. I am defining concrete, so I will select concrete. Uh, so I will select the customary. So these are the predefined concrete. Uh, these are the predefined concrete strengths that are already available in CSI Bridge for 4000 psi, 3000 psi, 5000 psi, and 6000 psi. But if you want to define your own, you can also define. For example, if you want to use 7000 psi strength, so you can also define that as well. So this is how you can define your own material. So you will select user instead of customer, you will select user and click OK. So this window will open up. You will change the name. For example, I want to define a 7000 psi concrete. Weight per unit volume is typical 150 pound per cubic feet is the standard weight of reinforced concrete. Modulus of elasticity, I told you that you can use this equation to calculate the modulus of elasticity if you are using the Newton millimeters. But if you are using the kip feet or pounds unit, so you can also use the other equation that is very common, ACI equation. You can also use that. That is 57,000 under root FC prime. So 57,000 under root the FC prime is a standard equation that the ACIA recommends for uh, calculation of modulus of elasticity, and this you can use up to strength up to I think 15 ksi or 10 ksi. So for strength up to 15 ksi. So this equation, this is the same equation, but these are also the same equation, but the units are changed. So the factors are also changed. This equation is applicable up to strength up to 15 ksi. So if you have strength up to 15 ksi, that is 15,000 psi. So you can use these equations. So 57,000 under root FC prime will so 57,000. I will first select FC prime 7,000. One thing more, when you use these equations, so these are unit sensitive equation. 57,000 under root FC prime uh, uh, is applicable only to PSI. So you when you use these equations, so the under root you have to place the unit strength in psi. If you use, for example, if you, let me finish this, then I will explain what I want to say. So this is the modulus of elasticity of the Poisson ratio is typical 0.2. All you all these values are the same for all grades of concrete, and specified strength will be 7,000 psi. Okay, so now I have defined my own concrete, that is 7,000 psi, which has a strength of 7,000 psi. So this is how you can define your own material as well. So I was discussing that when you use these equations, so you have to give consideration to the units. For example, if you are using this equation, so you have to put the value of concrete strength in MPa or Newton per millimeter. You have to use Newton per millimeter, uh, uh, Newton and millimeter units for the Newton per millimeter square for the for putting the value of concrete strength. For if you use kilonewton per millimeter instead of Newton per millimeter, or for example in the 57,000 under root FC prime equation, you use 7 KSI. For example, let's say if you use this equation and you put a value of 7 KSI instead of 7,000 PSI, so it will give you incorrect result. So you have to, all those equation in which squares, under roots and cubes are involved, so these are unit specific equations. You cannot use them for every units. For other units, the factor will be changed. So this thing, you should keep this thing in mind, that equation containing cube, under roots and squares, these are unit sensitive equations. So this is how you can define concrete. So I already had defined, or this is already present, the 4,000 psi concrete. So I will select this one. So under this tab, we have some another option, that is advanced property display. Switch to advanced property display. So for example, when I select this tab, so this this window will open. So these are advanced topics. I don't want to do not want to discuss. Material properties are temperature dependent. It depends. So for example, sometimes the material properties, for example, for steel, uh, the modulus of elasticity and other strengths are defined at normal room temperature. But if you are using constructing a bridge in higher temperature, then you have to check uh, these these bullets as well. Then it will take the temperature effects in designing in the bridge design. But these are usually done in nonlinear analysis. uh, mm, Modify show material properties. So when I click the advanced, then I will click on this modify show material properties, then it will open this. So non-linear material data, I am not discussing this. This is used for the hysteresis type, or for pushover analysis. Material damping properties, so this is also used for dynamic analysis. Time dependent properties, so time dependent properties, how many of you know about the creep and shrinkage properties of concrete? So anyone has any idea what the creep and shrinkage signifies in concrete? And anyone give me response, what does the creep and shrinkage mean in concrete? No one. Yes. Are you guys listening me? Hello?
Yes, we're listening. Yes, we're listening.
Okay. So creep is basically the deformation under sustained load, and shrinkage is the shrinkage in concrete occur due to the hydration of concrete materials for long term, because when in concrete cement is present, and cement two type of materials. One is the tri calcium silicate and one is the di calcium silicate. I don't know exactly which one uh, contribute toward the initial setting and which was contribute toward the final setting, but the concrete, the hydration reaction of concrete continues for a long period, and due to that hydration reaction the volume of concrete changes. But in typical concrete structures, for example in normal span 30 to 40 meter, we, due to the reduction, okay, this is so for typical bridges, we don't have any, we are not concerned with such type of material behavior. But for long span bridges, these things play a very significant role in their behavior. So if you want to consider the effect of these properties, then you have to design them use the advanced type of advanced material tab, and you have to signify, you have to put the values of all these factors, and the CSI will calculate the factors based on these advanced material properties. This you can also use this for automatic calculation of creep and shrinkage losses in pre-stresses, but for that you have to define construction stage analysis, and that's a very advanced topic in itself. So this was just to show you guys that you can, if someone of you have in future might come across any type of project in which you are asked to study the effect of creep, shrinkage, and the loss of stiffness due to long-term effects, so you can also do that in CSi Bridge. So this is all about material definition or concrete definition. Okay, so let me show you add new material. So similarly, just like concrete, we can define rebars as well. So rebars are typically already defined grade. These are the three grades that we use. And if I told you that if you have a grade that is not defined in the predefined library, you can define your own as well by using this user command. So the main thing is that you need yield stress, maximum tensile stress, all these things you can calculate, or the manufacturer will give you the detail of this. You just put them here and you can define your own material as well. So this is all about material. Let me check if there is any. So you can define tendon as well. So we have these grade 250, grade 270. So we do not now use this 250 grade because it is the industry does not use this no longer. It is no longer used in the industry. These are the different standards. So this is, others are something that, for example, if you have any special type of material that does not come under this category, so you can define it. And to define a material, what you need, that you just need the modulus of elasticity and weight per unit. And these are the typical properties on which any finite element program perform calculations. So these are the main properties for the definition of material. So these, you can use this step to define any type of new material that is not present in the CSI. So after the material definition, the next thing is frame section, frame properties. So let me repeat again. So the first, any in CSi Bridge, when we model, so we start from this layout tab. So layout tab is our first step, then component, then loads, then bridge, then analysis. So when you go from 1 to 5, at the end of 5, your modeling would be automatically complete. And it is a very CSI is very easy to use as compared to the other software, because of this feature that it had arranged the tab in such a way that when you go in a stepwise manner from one tab to another, at the end of this fifth tab you would have completed your modeling. Okay, so and these are for example material properties, frame section properties. These are required in all type of software, that is all type of bridge modeling software or building software. You can, these are the things that are common to all of them. So material definition and frame and section definition, this is common to all and you have to define them. But CSI has arranged the tabs in such a way that you can perform your bridge modeling very easily. The next step is frame section properties. So frame section properties are all the sections that are present in your drawing or in the bridge. So the frame section, the section properties includes the section of the superstructure beams, the substructure transom or bend caps, the piers or the bends, not the foundation but the piles. So all these you have to define. If you have any other type of sections, then you also have to define them. So all the sections that are included in your bridge, you have to define them using this tab. Okay. So just like the previous one, the first one is to define you. So when you click here, this window will open and it has the following type of sections. So for steel, built up steel section, steel is basically the structural steel. Built up steel section are these plate type of girders. So these are used in long span steel bridges. So these are not typically built in using a single form. You have to uh, cast these different component separately and then join them through welding or through nuts and bolts. So these are built up sections. These are the typical section that are available in the industry. Concrete, these are a typical concrete section. Aluminium, we don't use typically, but these are the typical sections. Cold form, these are cold form sections and other sections. So other section you can use for the all defining any type of section that is not available in this one. So we are using most, the case we are doing is concrete. So I will select concrete. So in this bridge, we have uh, these T-beams, these columns or piers and transoms or bend cap and piles. So I will define these four sections. But for this, in the latest version of CSi Bridge, we already have a superstructure module that automatically define this T type of section for you. So for T beams, you don't need to define these beam section for T type of T beam type of bridges. But for other bridges, for example, if you want to define your own type of section, or if you have a specific section in which the beam, it is not other than T beam section, you have to define your own. So for T beam, I will not define these beams because we have a template in the, I will show you the template. So in the superstructure, we have a template that automatically define the T beam section for us. So this is a tip already available built-in template that we can use for T beam definition, but you can define them from here as well. So I will define the columns. These are, let me check what is the dimension of these columns. Okay, 1 meter. So the pier is have a dia of 1 meter, so 1000 millimeter. So I am defining 1000 millimeter. So as it is circular, so I will select concrete It is a circular, so I will select circular type of section. Okay, so this the units are keep. I will first change the unit to millimeter. So you can change the unit from here as well. So kilonewton millimeter. I will define this circular. This is pier 1 meter. So 1000 millimeter. The material properties are 4000 psi concrete. So I will select this. Okay, section. So if when you define this pair, this tab will give you the section properties. So it gives you the cross section. This is the cross sectional area in milli. You have to check the unit here. What are the unit? Then these are the cross sectional area, moment of inertia about 3 axis, about 2 axis, all in the millimeter units. Time dependent properties. So I will not discuss this, but you can use this for advanced material property definition. Okay, anyone have idea about notional size? Do you know what notional size is? Does anybody have done any calculation related to pre-stress concrete, and they know about the shrinkage and creep calculation? So if you guys don't know, then I am not going to discuss this because it is a bit tricky. No idea. So let it be. I will not discuss this because I will show you a lecture tomorrow or slide, not tomorrow. Tomorrow we don't have a class, but in the coming class, what this means. Now leave it as it is because we are not performing time dependent analysis. So leave it as it is. Okay, so I told you that this is column. So when you define frame section in any CSI software, not only in CSi Bridge, but all the other CSI softwares. So you have to specify to a software that what type of element it is. It is a beam element or it is a column element. So how you can specify that? You will come to this concrete reinforcement. So there are two options, column. So it automatically has selected the column because you cannot have circular beams because we do not define circular beams. I haven't seen any circular beam in my life. So it automatically have selected this PM2 M3. So it will design the section for axial moment about 2 axis and moment about 3 axis. All of this we do not interfere with these value, but what you do that there are two options: reinforcement to be checked and reinforcement to be designed. So if you want the CSI to perform the design for you, so we do not change any of these value. But for example, if you have already defined a column and you want the CSI to check the reinforcement for you, then you will check this reinforcement to be checked and define the actual reinforcement here. So for example, I have this pair and it has let's say it has 24 number 8 bars. So and the clear cover is 40. For example, I am and longitudinal bar is 24 and it has a dia of number 8. So and confinement bar, so for example it has a spiral. These are the two options, spiral or tie. So I will select spiral and number 4 spiral with a pitch of 75 millimeter. So if I want the CSI to check my design, then I will put the actual values of the rebars and the spirals here and select this option, reinforcement to be checked. But if I want the CSI to design it for me and give me the reinforcement, then I will select this one. So you can also verify your design by using this option. And if you want to design a new section, so you select this option. The CSI will do the design for you. So this is now 1 meter pair. So as I told you that when you define a material, so you have two options to specify to CSI that what type of section it is. So now I have selected a rectangular section. So a beam can be rectangular. column and beam can be rectangular. So now we have these two options. Uh, 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 we have these two options available. So I will have to specify to the CSI that I am assigning this section to either a beam or a column. So if I am assigning it to a beam, then I will select this one. If I am assigning it to a column, then I will select this one. This is the rebar that we have to specify. Reinforcement configuration, for example, if this is a rectangular section, then you have to select rectangular configuration. If it is circular, then you have to select circular. So now this is what this concrete reinforcement tab mean. So I will stop the session here. After 10 minutes, I will start another session and we will discuss the other tabs as well.